All right, welcome everybody joining us on the recording. This is ACT, yes, ACT Math Crash Course Day 2, Part 1. We are picking up with the practice test we're working on from the last session, and we're going to see the level of difficulty get bumped up a little bit here today in some of these questions. We're starting with question number 23. Go ahead and read, if you will, Sarah, read that question for us loud and proud, please.
Yeah. Which of the following expressions is equivalent to... And then it has the expression.
Yeah, to that whole messy expression. Okay. A couple ways to do this. Of course, there's sort of an algebraic way to do this. We can distribute that 1/2 y squared. It's not too bad if you're familiar with the distributive property and you know how to work with variables. We're going to do that. But first, I want to practice the strategy of really simplifying this by turning these questions into basic arithmetic with plugging in values in place of the variables. Okay? So I want to come up with some values for x and y. Okay, and I want to set the x value here as 1 and the y value as 1. Okay, it may not be enough to eliminate all the incorrect answer choices. In fact, I don't think that'll be the case here if we plug these values, but it's going to really simplify it, right? And if we plug in a 1 for x and a 1 for y, what do we get in that expression there, Sarah? Can you work that out for me on the whiteboard?
Yeah. Okay, so... That's a messy too.
You're good. It is legible. Yeah, and that y squared automatically becomes. Yep, you're plugging there. You're plugging in. You're good. Yeah, go ahead and write it out by plugging it in first, and then we'll simplify it.
Okay.
The nice thing about plugging in a value like 1 is basically it melts away all of the variables. Because anything times 1 is itself. So the 1/2 is just going to become 1/2, and the 6x is just going to become 6, and the 2y is just going to become 2 ultimately. Does that make sense, Sarah?
Yes. Do you want me to keep writing it?
Yeah, go ahead and do it right now. I just want to make it clear. Again, anybody watching the recording, just so they know exactly kind of what we're doing here.
Okay.
It's looking good. Okay, great. Now let's simplify it, right? Because again, anything with a 1 is basically the ones are going to melt away.
Yeah.
Let's go ahead and simplify that just below.
Do you want me to write it?
Yeah, write it out. Yeah, simplified version just below would be great.
Okay. I'm gonna plug my mouse in.
Yeah.
Because that's really hard to write with the touchpad. Okay. So, well.
Is that mouse working, or do you need me to write it out?
No, it's working. So this would just be a 1. And this would be a...
Yeah, just go. I mean, look. I mean, 1/2 times 1 is just going to be 1/2, right?
Yeah.
And I know you're going step by step, and I appreciate that, right? But it's just going to be.
Do you just want to write it out?
Yeah. Let me write it out for you. I'll clear the space here. So it's going to be 1/2 times 6 plus 2 plus 12 minus 2. Right?
Okay.
Okay. Let's do some PEMDAS here. We got to calculate what's inside the parentheses first. Make it really clear. It's just 1/2 there. Okay. And what do we get inside the parentheses, Sarah?
6 and 2 is 8. 8 and 12 is 20. Minus 2 is 18.
Yeah, so it's going to be 18 parentheses times 1/2. What's 1/2 times 18?
9.
Just 9. Good old-fashioned 9. Okay. So when x is 1 and y is 1, we get a 9. Okay, does that make sense?
Yes.
Okay, so all we got to do now is plug those same values back into the answer choices, and the correct answer choice has to give us a 9. Does that make sense?
Yes.
Okay, if they're truly equivalent expressions, remember equivalent means equal. Okay, so let's plug those into answer choice A. What do we get for answer choice A?
9.
We get 9, so let's keep that. What do we get for answer choice B?
18.
That's 18, not 9, so B is gone. What do we get for C?
15.
15, right? Again, the nice thing about plugging in ones is that just everything with a variable essentially just kind of disappears. So it's just 3 plus 12. That's all that is. So that's not 9. What about D?
7.
7, not 9. So D is gone. And then what about E?
15 minus 2 is 12.
That is, well, we get 15. Let me see here. Minus 1. Yeah, that is. Is that 12? Hold on.
15 minus 3 is 12.
Yeah, you're right. So it should be answer choice A. Is that right?
Yes.
Yeah. Let me double check. I'm just double check something real quick. Yeah. You want to do the algebraic way real quick? I just want to double check.
Okay.
But I think it's that simple. It's the only one that gives us 9. Let's I calculated previously, and actually I got 2 answers that give me 9, but I clearly made a silly error there. Let's do the algebraic way. I was going to try to look up the answer key, but we can just do it with the algebra, and we can confirm it.
Okay.
All right. Okay. So algebraically here, we're just going to distribute that 1/2 y squared to all the terms, right, inside parentheses. You're going to multiply all those, woo, and then add them all up. So do you think you could work that out on the whiteboard?
Yes. Do you just want me to write what it would be? So just
yeah,
be 3x.
Yeah, you don't have to rewrite the question. Yep, just jump right into it. Wouldn't that be 12? Sorry, that would be 6xy squared.
6x,
right?
yeah.
Mm-hmm.
I don't know where the erase.
That's right. Don't worry about it. I'll just plug a x in there.
Okay.
Is that it? Yeah.
Yeah.
Okay, good.
So
Can we combine any of these like terms here?
Yes, these two would cancel each other.
Yep. Anything that's opposite added?
6 and 9. 6 and 3 would be 9.
Yeah, and when you've got like bases, which you have right here, you've got xy squared, you just add the coefficients. The coefficients being 6 and 3, so that's going to give us 9xy squared. So the algebra is not too complicated either. If you're really comfortable with variables, a lot of students aren't comfortable with the properties of variables, and so that's a bigger task for them. But again, you don't even need that here. Do you see that? If you can turn it into basic arithmetic by plugging in values for the variables. Does that make sense?
Yes.
Okay. And even if you see one like this, and you seem very comfortable with properties of exponents, very comfortable with the properties of variables. When you see some even higher level difficulty questions where the algebra is much more complicated, this strategy really, really shines. And so I recommend using it in general. Maybe even on an easier one like this, or maybe you can even check your work by plugging values for the variables if you have time. Okay. Any questions about that?
No.
Okay. Let's move along. All right, this is another one of the homework questions here. Go ahead and read question number 24 for me, please.
An artist makes a profit of 500p minus p squared dollars from selling p paintings. What is the fewest number of paintings the artist can sell to make a profit of at least $60,000?
Okay. This statement here, this whole 500p minus p squared, doesn't mean a whole lot to me. I don't quite know how to interpret that, okay? But I know p is the number of paintings, right?
Yeah.
They tell us that in the question. And then we've got 5 possible answer choices right here of possible numbers of paintings. Okay? Is there a way we can just test these answer choices and find what the fewest number of paintings is?
Could you plug it in?
I think we can plug it in. Okay. Let's do that, and we'll find the number that gives us the fewest number of possible paintings, right? As long as the profit is at least $60,000. Does that make sense?
Yes.
Okay, let's just plug them in. Do some arithmetic here.
Don't do that.
Oh, yeah. Go and plug it. Yeah, go and do it on the whiteboard, if you will, please.
Okay. Thanks. So, the first one would be 5,000 minus p squared.
Yeah, so that 500 times 100 just becomes, is that 5,000? I don't think it's 5,000. Why don't you double check? Yeah, double check in the calculator. I think it's going to be.
Yeah, it should have one more zero. Sorry.
There you go. Yeah. And the nice thing too, again, about the HT, every single question you can use the calculator on. I would use the calculator even on that because sometimes just keeping track of zeros is kind of a pain in the behind.
So that one's only 40,000.
That's 40,000, right? So we can eliminate answer choice F. Right? Doesn't give us 60,000. Let's try 150. Okay, I'll clear space on the whiteboard and just plug those values in. You can go use that calculator. I would like you to actually. You're going to have access to that on the test.
So 500 times 150 is 75,000 plus 150 squared, which is 22,500. It should be 97,500.
97,000?
Yes.
I think we're subtracting though here, right?
Oh yeah, I'm sorry, my bad.
Yeah, you're good. So let's subtract that. That might be enough.
So 75 minus. This is 52,500 instead.
That's oh, I see. Okay, 52,500.
Yes.
Okay. Not enough.
No.
Okay. All right. So let's try H. Let's try. We'll plug in 200 now. Okay. I'll clear our whiteboard again.
So 200 times 500 is 100,000.
Okay. I like that better already.
And then 200 squared is 40,000. So minus.
Ooh. That looks really good.
And this would be 60,000.
Well, there you go. Bingo. Answer choice H. Does that make sense?
Yes.
Is this different from how you probably would have approached it before we started working together on this? Or maybe not.
Probably, yes.
Yeah, I think most students, vast majority of students, their inclination is to set up an equation here. Or maybe even set up an inequality. God forbid, right? Which is just like a confusing equation, right? Which always throws students off. Students make silly mistakes on inequalities that they would never make on equations. Equations are complicated enough, but it just throws students off all the time. And then I wouldn't know how to solve it, honestly. I mean, I'm sure I could maybe figure it out, but I'd be like, you're guaranteed to get it by testing the answer choices. Does that make sense?
Yes.
This is the way to do it. I'm telling you, this whole test. You can make everything concrete. You can turn almost every single question into basic arithmetic. I don't recall, I'm not saying we didn't in the last session, but I don't recall a question where we had to do algebra, where we had to solve an equation. Do you recall any questions?
I don't think so.
I don't think so either. And we're almost halfway through the test. So you just don't need to get fancy on this, and I recommend keep it simple. You're not going to mess it up. As long as you can keep your signs straight and, punch in the right numbers into the calculator. And I'm serious. I'm making sure, be careful when you punch stuff in.
Yeah.
As long as you can do that, you're going to get a question like this right, no problem. Okay?
Okay.
It's all about simplifying the questions. If you can do that, you're going to rock this test. You got to think differently from math class, though. If you're in math class mode, all bets are off. But if you can simplify it and practice thinking about it like that, you're going to be good. I love this one. This is so great. Go ahead and read number 25 for me, please.
Last month, Lucci
Yeah,
had,
I think Lucy. I don't know. Yeah, why not Lucy? Could be Lucia or something. Go ahead.
had total expenditures of $900. The pie chart below breaks down these expenditures by category. The category in which Lucci's expenditures were greatest is what percent of her total expenditures, to the nearest 1%.
Okay. Slow down. Stop. Where is, on the pie graph, do you see where is her, the category for greatest total expenditures?
Oh, you just want the one with the greatest amount?
Yeah, which one is it?
Okay, they're her clothes.
Her clothes, right? Her clothes. I'm avoiding so many jokes right now. So many. Trying to suppress them all. And doing a pretty good job at the moment. Yes, she spends a lot of money on clothes. Okay. Forget about the math right now. Forget about math. Let's just look at that little piece of pie on that pie chart, right? Because you know what like 50% looks like, right? You know what 25% looks like, right? On a pie chart, right?
Yes.
Right? What percent, if you're going to guess, don't even look at the answer choices, don't do any math here, just take a look at that part of the pie. What percentage of the pie, if you were going to guess, what percentage of the pie would you say that is?
It looks like a little bit more than a fourth of the pie.
So what percentage? I agree. It's a little bit more than a quarter of the pie. What percentage? Don't even look at the answer choices. Just tell me what percentage would you guess?
Maybe like a third of it.
Well, that's not a percentage, right? That's a fraction.
Oh, okay. So 25-ish percent.
25-ish percent?
Yeah.
But bigger than 25, right?
Yes, because 25 would be a fourth, and it's a little bit bigger.
Yeah, just a little bit bigger. Is it a third? Is it 33%?
Somewhere maybe between.
Take a look at the answer choices.
So 24 would be too small.
Definitely too small. It's not a, can't be a.
28 would be in between those. So would 32. 39 is way too big.
39 is way too big, for sure.
34 is probably going to be too big.
34 is too big. It's not a third, right? It's not a third. You know what a third looks like, right? My third is like the peace sign, right? That's a third.
Honestly, I would go with 28.
I'd go with 28
just going to guess.
if you were just going to guess. Absolutely. And if you went with 28, you get this one right. Because it's just like you said, it's just a little bigger than a fourth. Fourth is 25%, right?
Mm-hmm.
Does that make sense?
Yeah.
This is drawn to scale. Every single question on the ACT that I've ever seen is drawn to scale. So if it looks like it's half, it's half. If it looks like 25%, it's 25%. Does that make sense?
Yeah.
Now, I bet we can do the math on this. We're gonna do the math, real quick. It's not complicated. I just want to show you that you can really simplify this, and especially if you're in a bind and you don't have a lot of time and you've got to slap down an answer. Just look at it and be like, I don't know. I would guess 28%, and you'd be right if you did that. Does that make sense?
Yes.
Okay, let's confirm it real quick with the math. So how would we find what percent? So it's $254 out of 900 total. How do we find what percent that is?
What percent of 900 equals 254?
Yeah. How do you find that? Right, is my question.
Oh, okay. X over 100 times 900 equals 254.
Go ahead and set that up. I'm not saying. Yeah, let me see that. That's not quite how I would do it. But let me see what you're gonna do.
So.
Can you work this out on the whiteboard?
Is it not showing up?
Oh, let me zoom out a little bit. Oh, there we go. Okay.
Sorry.
Yeah, you're good. I was just zoomed in. Divide both sides by 900. Looks good.
So I'm just going to do it on my calculator. 1, 2. 28.22222.
That sounds pretty good to me.
Yeah.
And it looks like it, right?
Yes.
Does that make sense?
Yes.
Another way to do it, and probably what I'd recommend for most students, if you know the part that you've got, a part of some whole, just divide the part by the whole and you'll get the percent every time. Right? And maybe this comes really natural to me as a teacher, right? Because I've corrected a lot of tests, right? But if it's like a 50 question test and the student got like 43 questions right on a 50 question test and I wanted the percent, I could do this whole deal. I mean, potentially. I was trying to circle it. I could do that, or I could just divide 43 by 50.
Okay.
What does that give me if I divide 43 by 50?
43 divided by 50 is 0.86.
Yeah, 0.86 or 86%. Right? Does that sound right? If you got 43 questions out of 50 right on a test, that'd be 86%?
Yeah.
Yeah, that's the way it works. So all we literally need to do is take the part and divide by the whole. Take the 254, divide by 900. What's 254 divided by 900?
0.28.
0.28, which is the same as 28%.
Mm-hmm.
Does that make sense?
Yes.
8%. Did we talk about percent increase? I think we did in the previous class, right? We did already, I think, cover it to some extent.
Yes.
Percent means out of 100, all that, yeah. Okay. Any questions about that?
No.
Okay. But we see again, like you can just use basic visual estimation for that question. Really easy. Really easy. And that might be the best way to do that. Boy, it might be. You're guaranteed to get it. All right. Let's.
Yeah.
It's a different test than everybody thinks it is. It really is just a logic test. And much less a math test. Question 26. Go ahead and read this guy for me, please. I like this one too.
In the figure shown below, the measure of angle BAC is x plus 20 degrees, and the measure of angle BAD is 90 degrees. What is the measure of angle CAD?
Okay, which one are we solving for? Where's CAD? Can you find that on the figure? Which one is that?
Yeah. It's right there.
Yeah, that's the guy. That's CAD right there. Yeah. Okay, so angle CAD. What's the measure of angle CAD? Okay. Well, let's do this. If you were going to guess what CAD is, like just visual estimation, what would you guess?
So it's BAD is 90, and it looks maybe like half of 90, so maybe 45-ish.
Yeah, I mean, does it look like half? Does it really look like half of 90? Do those two angles look equal?
No, it looks a little bit bigger than half.
It's a little bit bigger than half, right? So give me another guess.
Maybe 50.
Yeah, 50 is a great guess, right? It's close to half, but it's a little bigger than half. So let's say BAD is 50 degrees. Does that make sense?
Yes.
Okay. And that would make BAC how many degrees?
BAC, 40.
That'd be 40 degrees, right? They got to both add up to 90 degrees. Does that make sense?
Yes.
Okay. All right, so notice I don't see a 50 in any of the answer choices, but they tell us that BAC is x plus 20. And if BAC is x plus 20, what's x going to be?
Wait. 80. Oh, wait,
Well,
no, 60, sorry.
No. If BAC is x plus 20, this part right here.
Yes.
Right, BAC is 40 degrees. What does x have to be?
Okay.
What does x have to be?
Oh, okay, 20 degrees. 20
degrees. Or just 20, right? Yeah.
Yeah.
Okay. Does that make sense so far?
Yes.
I'm just trying to think in concrete terms here. I don't want to deal with equations. I'm going to deal with real values here. Okay. So if x is 20 then, what answer choice gives us the measure of CAD?
70 minus, so G, 70 minus 20 would be 50.
It's got to be G. It's the only one that gives us 50, right? When x is 20. Look at, yes, what's up? Clever. What's up?
Amazon's here.
Okay, great. Just let me at the door, okay? Daddy's recording right now, okay, Pumpkin? Okay. All right, I love you. Sorry, my 5-year-old walked in. It may happen. I'm babysitting right now, so there may be more children coming in. All right, there may be a diaper change break coming up at some point. But anyway, we'll figure that all out. So it's got to be G, right? I mean, F gives you what? When X is 20, what does F give you?
-50.
Negative. That's crazy. What about H?
90.
90. Look, I mean, just CAD is just not 90 degrees. And look at J and K. I mean, come on.
Yeah.
Right? Does that make sense?
Yes.
Just make it concrete. Start dealing with real values. We can eliminate all the wrong ones. We can confirm the right one. We're dealing with real values. Any questions about this?
Mm-mm.
There might be a more algebraic way to solve this. I'm guessing there is. I don't know what it is. I don't care. I don't want to know. Just make it concrete.
Okay.
It's so easy. Does that make sense?
Yes.
Okay. I mean, almost any time they give you variables in the answer choices, there's a way of plugging in values and making it concrete. Almost every time. That's certainly the case here. All right, let's do a new one here. Question 27. We're getting into some more geometry. There's a healthy amount of geometry on the ACT. The good news is it's all really easy. You can use visual estimation on almost everything. Go and read 27, please.
What is the perimeter in inches of the isosceles right triangle shown below, whose hypotenuse is 8 square root 2 inches long?
Okay. The hypotenuse is 8 root 2 inches long. First of all, let's talk about some vocab here. You know what a hypotenuse is, right?
Yes.
What is a hypotenuse?
It's the longest side of the triangle.
Always the longest side of a right triangle, right? Always
Yeah.
the longest side. And it's the side that's across of 90 degrees. So which side is the hypotenuse here in this triangle?
This side right here.
Yeah, this guy. This side. The hypotenuse across from the 90 degree angle, and it's the long side. Okay. So they tell us in the question the hypotenuse is 8 root 2 inches long. Okay. There's two things. One, I want to deal with real values here. I don't want to do any fancy equations or anything crazy like that. I want real numbers, and I don't like seeing radicals because I don't like dealing with those. Okay, I like basic numbers. I can deal with decimals and fractions, but radicals students really struggle with, and they have funky properties that nobody remembers. So let's turn that into an actual number. You know what I'm saying? Find out what 8 root 2 is. Does that make sense?
Yes.
So what is 8 root 2? So we got to find out what root 2 is, and you just do this on a basic calculator. Find out what root 2 is, then multiply it by 8, and we'll find out what 8 root 2 is.
When I plugged in, I got 11.31.
11.3. 11.3. Okay. Good. All right, so if that hypotenuse is 11.3, how long are the other sides? We're trying to find the perimeter ultimately, so we got to guess what the other sides are. Give me an estimate what the other sides are.
They have to be less than that.
Less than that, for sure. But not a ton less, right?
Equal because it's an isosceles.
Yeah, exactly, right? So give me some values. I want to deal with real values.
I don't know, maybe 7, 9.
7 or 9? I think either of those are pretty reasonable. Maybe something in between.
Yeah, 8.
8 would be great. Right?
Oh, looking at the answer choices, yeah, 8 would be
8 would be great. Yeah, let's do that. Let's pick right between those two values. 8 and 8. And if you got 7 or 9, I don't think it would be a big problem. But 8 just feels right anyway. Right? I mean, imagine, that dropping that side down, compare it. You know what I'm saying? That side's going down. If that's 11, then, yeah, 8 sounds like a pretty reasonable estimate. You know what I'm saying?
Yeah.
And here you could also do the bootleg ruler. Have we done the bootleg ruler? I don't recall from the last session. I really don't. I apologize. Did I show you the bootleg ruler?
I think so, but I don't remember, honestly.
It's where you compare a known value to an unknown value. Let's do it real quick. I think it's going to be handy here.
Oh, at the side of your paper.
Yeah. You did it, right?
Yes.
So you could literally, I would measure the 11.3 and then compare that 11.3 to the other unknown sides. And something like 8 would just be a great guess.
Okay.
Does that make sense?
Yes.
Okay, good. All right, so this is good. Now, what's the perimeter here of that triangle with those values?
Using the decimal,
yeah, let's just add it all.
16 plus 11.3.
Which is what?
27.3.
27.3. Okay. And I know, again, we're just estimating here, so I'm not necessarily expecting this to be perfect, but the correct answer choice should be something close to 27.3. Does that make sense?
Yes.
Look at the answer choices. Look at answer choice A.
Yeah, you can eliminate that.
That's silly. What about B?
It's too small. Eliminate it.
Too small. What about C?
Yeah.
Let's calculate that.
Okay. So 16 square root 2 is 22.6, and then you have to add that to the 8.
What do you get?
6. It's too big.
What did you get?
30.6.
Yeah, it's close. I'd be tempted to keep it.
Okay.
Try D.
No.
Well, that's silly, right? What about E?
So 8 square root of 2 is 11.3 plus 16, 27.3.
Well, there you go. Okay. Which makes a lot of sense now that I'm looking at it, right? Because that 16 probably came from the two sides right here being added.
Yeah.
Right? And then 11.3 is just 8.2.
Mm-hmm.
Does that make sense?
Yes.
Okay. That's better than C. So C's gone. Make it concrete. Use visual estimation. You don't have to get fancy. Does that make sense?
Yes.
All right. Let's go on here. Number 28. E. Oh boy. I don't want to focus this one here. Go and read 28 for me, please.
The equation y equals ax squared plus bx plus c is graphed in the standard xy coordinate plane below for real values of a, b, and c. When y equals 0, which of the following best describes the solutions for x?
Okay, before we read the answer choice here, let's talk about y equals 0. What does that look like for y equals 0?
Okay, when y equals 0,
And that's a line, right?
it's just a line on the x-axis.
Yeah, literally runs, it overlaps the x-axis, right? That's the line y equals 0 right there.
Yeah.
Does that make sense?
Yes.
Okay. And this is something that pops up on the ACT and the SAT, and I want to make it really, really clear. And I've got it, actually, it's one of the basic concepts on the rules for ACT math. Let me bring that up here. Zoom in just a little bit. And put this here, graphing here. Okay, go ahead and read that first bullet point here for basic concept H, graphing.
The y value at the x-intercepts is always 0, and when the x value at the y-intercept is always 0.
Yeah, stop and think about that for a minute. Does that make sense? Why on the x-axis, right? The x, wherever a line or a parabola or anything intercepts the x-axis, the y value is always 0. Does that make sense?
Yes.
Okay. And the same thing, the x value on the y-axis or the y-intercept is also always 0. That's just the x value has to be that case. Okay.
Yes.
All right. And then I think the second bullet point here is going to be relevant too. Go and read that second bullet point.
The points where two lines meet is the solution to a system of equations.
Yeah. Okay, and we've got basically two equations meeting here, two lines in this question, and that's going to be the solution. All right, so let's test the answer choices now. Do we see where the solution to this system is, right? Where these two lines meet, where the parabola and the line meet.
Oh, yes.
Is that obvious, right? These points right here and right here. Okay. Let's just test the answer choices now. Different color there. Okay. Go ahead and read answer choice F for me, please.
Two distinct positive real solutions.
Okay. Does that describe the solutions for X? Do we see two distinct positive real solutions?
Well, once you're to the left side of the x-axis, it's negative.
Yeah, anything on this side right here, that's going to be, there's going to be negative values for X, right? And they're asking us which of the following best describes the solutions for X. So it
couldn't be that one.
This one's positive over here, whatever that is. I don't know what it is. But it can't be F, right? Because both aren't positive. Try G.
The two distinct negative real solutions. One of them's not negative.
One of them's not negative, so G's gone. What about H?
One real positive solution and one negative real solution. Yes.
That sounds pretty good. Okay. Let's check the others, though. Check.
Two real solutions that are not distinct.
Yeah, distinct just means kind of different, right? Do we have two different solutions?
No.
We don't have two different solutions for x?
Or we do have two different solutions.
We do, yeah. I mean, we just said already, right? One's positive, one's negative. They're definitely different, right? These two different points. They are different.
Mm-hmm.
So, I don't like J. What about K?
Two distinct solutions that are not real.
Yeah, I'm not even sure what that would look like. What not real solutions would look like on a graph. I don't know. I mean, we're not talking about imaginary numbers here.
Yeah.
Right. I mean, these are real values for x. It's just not. It's not a thing. So that's H. Any questions about that?
No.
They're almost testing you on definitions here, right? Do you know what a real solution is?
Yes.
You know what a positive real solution is, right? I mean, like if it's on the xy axis, it's a real solution. You know, you don't graph imaginary numbers on an xy axis.
Yeah.
And I think we were going to see a question with imaginary numbers coming up here in just a little bit. We'll talk about those, but these are definitely a real solution here. Okay.
That breaks it down a lot easier. You don't even have to use the equation they put in there.
No, gosh, no. No, I wouldn't. I don't know how you would.
I don't know.
I don't know. Don't even think about it. Yeah, I mean, I'm looking at a picture, right? Like, yeah, that's it. That's it. Just remember, and it pops up quite a bit on the ACT and the SAT, right? Where lines intersect, that's the solution. So that's it. There's two solutions here. One value for x is positive, one's negative. It's real simple, right? It's just kind of you realizing that it's a simple question, and that's not easy always to realize how simple something is, which is so ironic. All right, but let's go to, in fact, here we go, imaginary numbers. What perfection. All right, go and read question number 29 for me, please.
What is the product of the complex numbers negative 3i plus 4 and 3i plus 4?
Yeah, product here. Let's talk about product. Here's a definition we got to know. What is a product? What does that mean?
When you multiply them, it's the answer.
Yeah, when you multiply, and that's such like a third grade term. I remember hearing that in third grade and be like, when am I ever going to use this? Like, I just could not talk about multiplication, but I guess it's handy to know for the ACT. So thanks, third grade math teacher, Mrs. Boggs. In fact, I can't believe I remember that, Mrs. Boggs. Oh boy. All right. All right. So yeah, so we're talking about multiplying these two. And these are, we've got imaginary numbers here. Okay. So let's talk real quick about imaginary numbers first. And I think I've got a section here on the basic concept cheat sheet. Here we go. Basic concept I. Oh, perfect. How that lined up. Go and read that first bullet point, the only bullet point for imaginary numbers, please.
For imaginary numbers, treat them just like any other variable, except I squared equals negative 1.
Yeah, except I squared equals negative 1. Let's talk about imaginary numbers. This throws students off a little bit because they don't really understand what it means. First of all, don't complicate it, right? Because you treat I just like you treat x, like any other variable, or like I, right? So all the rules that you know for dealing with variables works the same. You just add the coefficients. X times x is x squared. I times I is I squared, right? But I want you to understand kind of what imaginary number is. So let's talk about square roots. So let's say the square root of 16. What does that equal?
4.
That equals 4, right? And the question is, there's some number times itself that gives you 16. And that number, very simply, is 4, right? Or the square root of 9, right, is 3, right? Because there's some number times itself that gives you 9, and that number is 3, okay? So here's where imaginary numbers come into play. What's the square root of negative 1? Okay.
You can't do it.
You can't do it, right? There's a known real number, at least, that when you multiply by itself will give you negative 1, right? Because if it's a positive number, positive times positive is positive. But even if it's a negative number, like negative 1, right? Negative 1 times a negative 1 is still going to be positive 1. There's no number you multiply by itself that'll give you any negative or negative 1. So they call that I, an imaginary number. Does that make sense?
Yes.
Okay. But that's why when you see I squared, right, this the to the power of 2 essentially cancels out the root sign. And so I squared just equals negative 1. Okay, and I think that's going to come to play in here, in this question. That's why I just want to go over imaginary numbers, because we're going to talk about the properties of I, and we'll see that play out. Okay, any questions about that? Or is that straightforward?
Yeah, I understand.
Okay, all right, great. So I'm going to clear that real quick. So let's find the product of these complex numbers here, and this is where we've got another basic concept that's going to come into play, and that's foiling. Okay, you've seen foiling before. You've heard of foiling?
Yes.
It's handy to know. right? The FOIL method, when we've got some polynomial that's been factored, FOIL is an acronym stands for first. Does I have inner first here? I need to fix that. It's outer. Oh boy. Doesn't really matter, actually. It could be fuel. But first outer, inner, last. So let's do that FOIL method here when we multiply these two. So we've got negative 3i plus 4 times 3i plus 4. Can I see you do the FOIL method here? And multiply the firsts.
Yeah.
Show me what we get. Yep, negative 9i squared. Yep. So we got the first, that's where that negative 9i squared comes from, and then the outers. That's where that negative 12i comes from, and the inner, that's where positive 12i comes from, and then the lasts, that 4 times 4 gives us 16. Now we've got two opposites here, right?
Yeah, so they cancel
so those
out.
cancel each other out. And that gives us what?
9 plus 16 is 25.
Yeah, so I squared, remember, is negative 1. So that gives us negative 9 times negative 1, which gives us 9 plus 16. You said it gives us what? 25.
25.
25, which is our answer. That's choice C. Any questions about that?
No.
No. There's also something called really difference of squares right here. I don't know, have you heard of difference of squares? Maybe, maybe not.
Maybe.
Okay, don't worry about it. You don't need to know it here. It's got a. Don't worry about that. I probably shouldn't have brought that up because we're already talking about foiling and imaginary numbers in one problem, so I don't want to complicate it. But that's it. Gives you 25. All right. Let's go to the next. Yeah, one of the trickiest parts with imaginary numbers is realizing how simple they actually are. If you know how to deal with variables, you know how to deal with imaginary numbers. Except for that I squared mean negative 1. Go to question number 30 for me. We've got some trigonometry going on here.
The radius of the base of the right circular cone shown below is 5 inches, and the height of the cone is 7 inches. Solving which of the following equations gives the measure theta of the angle formed by a slant height of the cone and a radius?
Okay. Yikes. Solving for which of the following equations gives the measure theta of the angle formed by... Okay. Let's do this. I haven't solved this one recently. It's been a while. Here's what I want to do. I want to make this concrete again. Okay, we could do some trigonometry. We could do some Sohcahtoa. I think we're going to do that here in just a minute. But I want to see if I can eliminate some incorrect answer choices, maybe even all of them, with some basic visual estimation. If you're going to guess what angle that angle theta is, what would you guess?
So I know that one's 90. And that's going to be less than 90, I think.
Definitely less. I mean, come on. It's definitely less than 90. Has to be. Right? You know what 90 looks like.
Yeah, you could put the corner of your to it.
Yeah, you could bust out the bootleg protractor. Did I show you the bootleg protractor? Have we done that yet?
I don't think so.
No, we've not. We've not. Let me go to the camera here. I need to inform everybody that every SAT gives you a protractor along with a ruler, right? Because you can turn a piece of paper into a ruler. They also give you a protractor. They give you a perfect 90-degree angle on every ACT. Comes automatically, right? 90 degrees, so you can compare any corner to any angle and make a reasonable estimate. If you need a 45-degree angle, just fold it in half. And suddenly you have a perfect 45-degree angle right there. If you need a 30-degree angle, just draw like 3 lines, kind of separate that 90-degree angle perfectly, fold along the lines, you got a 30-degree angle. So you can always use basic visual estimation and use that bootleg protractor for any questions with angles. This is the case here. All right, so if you're going to guess what that angle theta is, what would you guess?
30.
That looks like 30? That's bigger than that's
No.
more than half a 90. Don't get me wrong, I mean, like, theta's the one inside the triangle right here.
Yeah. So 45?
Does that look like half of 90?
No, it looks like less than half of 90.
Wait, hold on. Are we talking about the same angle here? Let me erase my markings here. 45 degrees is half of 90.
Yeah.
Okay. Don't get me wrong. It's somewhat. So I can do even better job here. Somewhat close. That's pretty good right there. It's somewhat close to half. Boy, I would say that's a little bit bigger than half.
It's bigger than half.
Just
okay,
a little bit bigger. And you can check that with your 45-degree angle. Do it, in fact. Right? I'm going to do it too. Is that bigger than... Oh, that's definitely bigger than half. Come on. What are you going to guess? What is that? How many degrees?
50, 55.
I would totally guess, 55. That's what I would guess. Okay? That's what I would guess. So it's around 55 degrees. Okay? That makes sense?
Mm-hmm.
All right. So let's find out what the tangent of 55 degrees is.
Okay.
All right? And you can find that out on your, calculator.
It is 1.4.
1.4, which does not equal 5/7, right? I'm testing answer choice F here. Does that make sense?
Yeah.
Yeah. So, I don't like that. Let's try the tangent of theta. Oh, wait, hey, that's the same thing. We already did that. What did we say it was?
We said it was 1.4.
1.4. What's 7 divided by 5?
7 divided by 5 is 1.4.
Oh my! That's funny. That is funny. Hold on, let's keep that. I don't know if that's the right answer or not, because we might get another answer choice that gives us a true statement, so we got to cycle through. But I didn't realize how precise our 55-degree guess was. If I were just going to guess looking at visual, that'd be like 60 degrees. That's what I would say. But I like our 55. That was using that bootleg protractor. So let's keep G. What about H? What's the sine of 55 degrees, right? Theta is 55 degrees.
So sine of 55 is 0.82.
Is 5 divided by 7 is not 0.82, is it? What's 5 divided by 7?
No, it's not. 5 divided by 7 is 0.71.
Yeah, I don't like that. I don't like it. I could be wrong, but I don't like that. Try J.
7 divided by 5 is 1.4.
And this, okay, right? And we already said that it can't be it.
Yeah.
What about K?
Cosine 55 is 0.57, and 7 divided by 5 is 1.4.
Boy. I don't like that. I think it's G. I'm not certain. I'll be honest. I really don't know. I mean, I'm amazed that we got, that precise. What the other reasonable answer choice, again, because we're basing this theta value on visual estimation. The other reasonable one was what, H, did we say? That was pretty reasonable. They gave us 0.82 or something like that.
Yeah,
which is close to 5/7. Okay. Let's see if we can confirm this using some good old-fashioned Sohcahtoa. Are you familiar with Sohcahtoa? Have you seen that before?
I have.
Yeah.
Yeah.
Let's go over it real quick for those, anybody watching the recording. So Sohcahtoa is an acronym for basically the relationship between sine, cosine, tangent, and then the sides of a triangle. So sine equals opposite over adjacent, cosine equals adjacent over hypotenuse, tangent equals opposite over hypotenuse, and that's where the letters from Sohcahtoa come from. Okay. So let's see if we can use Sohcahtoa here. So we're trying to find. Well, let's just try to confirm G. Answer choice G real quick. So using Sohcahtoa, right, the TOA, tangent of theta is going to equal the opposite over the adjacent. That make sense?
Yes.
Okay. And what is the side opposite theta?
7.
7. And then what's the adjacent of theta?
5.
5. Boy, that's really easy too. If you know Sohcahtoa, that's really easy. Yeah. So we can confirm it as answer choice G. It might be easier just doing Sohcahtoa there. Right? I mean, really, if you're familiar with it.
Yeah. That's probably what I would have done.
Yeah, and it's not a bad idea. There are some cases, though, where quite a few, especially, this is a really easy one, if you're familiar with Sohcahtoa. There are a good number of trigonometry ones where the operation is not obvious, but if you start dealing with visual estimation root values, you can confirm it.
Okay.
Yeah. But anyway, I'm so proud of our estimate of 55 degrees. I think that's fantastic.
It took a second to get there, but yes.
Yeah, it did. It did. Now, it's so funny, right? You may not be. A lot of students aren't used to like using like estimating visually, which is funny. I get it. They don't teach it to you, but it's like if anything's gonna be useful in life, boy, let me tell you. I mean, like, kind of learn to eyeball things, and maybe it's my experience doing like woodworking and measuring and stuff like that as a kid. I'm not quite sure what it is exactly, but.
Yes.
But with a little practice, anybody can do. I mean, just what half of 90 looks like. Come on, you know what half of anything looks like. Just practice thinking in those terms, right? And theta is clearly bigger than half of 90, right? Is that obvious now?
Yes.
But just a little bit bigger. It's like 50 is a really reasonable guess. 55 is a great guess. Spot on. Okay, but again, you see that everything's drawn to scale in the ACT. Everything. Okay. Hey, got some more probability. I don't think we need to do this probability? It pops up a lot in the ACT. Let's do it again.
Okay.
Right. Go ahead and read question 31 for me, please.
To make a 750-piece jigsaw puzzle more challenging, a puzzle company includes 5 extra pieces in the box along with the 750 pieces, and those 5 extra pieces do not fit anywhere in the puzzle. If you buy such a puzzle box, break the seal on the box and immediately select one piece at random, what is the probability that it will be one of the extra pieces?
What is the probability that it will be one of the extra pieces? Let's talk about probability real quick here. Let's go back to the rules for ACT math. And where is probability on here? Basic concept A. Okay. I gave you a definition of probability that it's winners, right? The winning outcomes, the outcomes you're looking for divided by the total number of possible outcomes. Okay. And I think I said also in the last session that always start with the denominator. Always start with the total number of possible outcomes. Okay. And then we'll pick the winning outcome from within that total number of possible outcomes. Okay. So here they're saying if you buy such a puzzle box, select one piece at random, what is the probability that it will be one of the extra pieces? Well, what's our total number of possible outcomes here?
So if you add the 5 extra pieces in, you're going to have 755 pieces.
Yeah, we're talking about picking one puzzle piece from amongst the 755 total, right, that are in the box. So that the denominator's got to be 755. Does that make sense?
Yes.
Okay. And just starting there, I feel pretty comfortable eliminating some answer choices. I guess we could simplify and get something else, but I would say B and D are already looking pretty good.
Yeah.
But what is our winning outcome? What is our winning outcome?
You just want one of the pieces.
You want one of which pieces?
One of the extra 5.
One of the extra pieces. And how many winning outcomes are there?
There's 5 extra pieces.
There's 5 extra pieces, therefore 5 winning outcomes. So 5 out of 755. Answer choice D. That's not bad, is it?
No.
No. I think it's just honestly it's like a reading question. Just being comfortable with what the situation they're describing. But once you understand that, then it's pretty straightforward. You got to recognize we're talking about 755 pieces total.
Mm-hmm.
And not just 750. Any questions about that?
No.
No? Okay. Let's do one more, and then we're going to take a couple-minute break here. Number 32. Let's see what's going on with you. You know, it's funny. I always tell students that take the ACT that questions 1 through 30 should be a breeze. 1 through 30. And it's funny seeing questions like 31, even 32 here. This is real straightforward. We can make this real straightforward. Maybe questions 1 through 40 are just, you're going to see easy to intermediate level questions, 1 through 40. You know, you might see a couple tough ones peppered in there in the 30s. It's all real. So you should be nailing 1 through 30 and most of 1 through 40. No problem. Go to read question 32 for me, please. This is not bad.
What fraction lies exactly halfway between 2/3 and 3/4?
Let me remind you and anybody watching this recording that you have a calculator at all times on the ACT. You never need to deal with fractions, ever. And that's good news, okay? Because most students really struggle with properties of fractions, adding, subtracting, multiplying, especially adding, subtracting. You got to get that whole common denominator going on. Let's turn these into decimals. What's 2/3 as a decimal? What's 2/3 as a decimal?
Okay.
2 divided by 3, right? In your calculator.
Yeah, it's 0.66 or 0.67,
yeah,
I guess.
0.66666 or 0.667, right? 0.666 repeating. Okay. What about 3/4? You run the calculator.
0.75.
0.75. Does that make sense?
Yeah.
Okay. What number's halfway between those two?
Anything between 0.667 and
Yeah, it's got to be
0.75.
between those two. I'm guessing a lot of the answer choices are going to be between those. Maybe not. Maybe not. Let's see if we can eliminate some obviously incorrect ones. Look at answer choice F. What's that equal?
0.6.
Ha! Point that's not even between them. Right? Ridiculous. Ridiculous. What about G?
0.83.
Come on. This test is so easy.
0.58.
Oh my gosh. It can't be this easy. It can't. But maybe it is.
0.56.
No! Are you kidding me?
And 0.71.
Does that sound like halfway between?
Yeah.
Oh, yeah. We got BK. Oh my gosh! How easy is that?
It's a lot simpler.
So easy. And you totally, I'm learning more about you, Sarah, and I'm guessing you would totally do like the fraction operation here, right? Maybe add them together and find the average.
I would have made them common denominators and gone from there.
Of course. You've been trained well. But that does not play your advantage here on this test. Not necessarily. You can simplify all these. You never have to deal with fractions. Don't. I'm not saying you look, you could probably get this. You're a bright girl. But you're guaranteed to get it with a calculator. And it's going to save you a lot of time. Now, this is a fancy way, by the way, of asking you, where they say which lies halfway between, exactly halfway between. They're asking you what's the average of those two. So let's find the average of these real quick. What's the average of 0.667 and 0.75? How do we find the average?
You add them together and divide by 2.
Add them up, divide by 2. What do we get?
So 0.667 plus 0.75 divided by 2 is 0.71.
0.71. And what did we get when we divided 17 divided by 24? What did we get?
0.71.
Bingo! This is not a math test, Sarah. This is a logic test. And they give you a freaking calculator on it. So easy. This question is so easy. Okay. Simplify these questions.
Yeah.
All right. Let's take a little 3-ish minute break. Maybe let's take a little 5-minute break, actually. And I'm going to run to the restroom.
Okay.
And drink some more coffee. And I will see you in about 5 minutes, okay?
Okay.
All right. Thanks, Sarah. See you soon.